Good morning, class. Today I'll be teaching you guys about Chapter 4 of AP Statistics Review. We're going to be looking at collecting data, specifically sampling and surveys first. So let's look at our first key terms that we need to recognize, which is population, census, and sample. So population in a statistical study is the entire group of individuals that we want to inform about. Census collects data from every individual in the population. And then a sample is a subset of individuals in a population from which we actually collect data from. So we collect data from a representative sample to make an inference about a population. So you take a sample from a population to make an inference about the larger population. So we often draw conclusions about a whole population on the basis of a sample survey. So choosing a sample from a very large varied population is not that easy though. And so we're going to look at different ways which we can do these surveys. But let's look at how we can sample badly. So choosing individuals from a population who are easy to reach results in convenient sampling. So we don't want to do that because we can't generalize about the population when our sample doesn't represent the full population. Other ways we can do this incorrectly is if the study has bias. So bias occurs when the people from the survey, basically like their interests can interfere with like the generalization about the population. So another way is voluntary response sampling, which what this can lead to is people that respond to the survey are either like very against or for that specific thing that you're surveying about, because the only people responding to a survey are likely going to be the people who are very interested in that subject. So it doesn't represent the full population, and so those are ways to sample badly. Way to sample well is to use a random sampling method. So this involves chance to determine the members of the population. A simple random sample of any size is chosen in a way that every group of n individuals in the population has an equal chance of being selected. So this allows to be generalized to the population because the people in the sample are random. So one way that we can do a simple random sample, or an SRS, is with technology. This is going to be your easiest way to do it. You're going to want to label, randomize, and then select. So to label, you give each individual in the population a distinct numerical label. To randomize, you use a random number generator to obtain n different integers from 1 to n, where n is the sample size. So to select, you choose the individuals that correspond to the randomly selected integers, and then you have your simple random sample. I also want to talk about other sampling methods. So an SRS is the most common way to randomly sample a population, but there's also systematic random sampling, which selects a sample from an ordered arrangement of the population by selecting one of the first individuals and choosing every nth individual thereafter. Ways sample surveys can go wrong. Undercoverage can occur when some of the members of the population are less likely to be chosen or cannot be chosen in a sample. Non-response, which occurs where an individual chosen for the sample can't be contacted or refuses to participate. So if we sent out a letter to 1,000 different people in Temecula, and then we had people that wouldn't respond, that would be non-response. Response bias occurs when there's a systematic pattern of inaccurate answers to a survey question. So that's what can go wrong in sample surveys. Then I also want to talk about experiments. So sample surveys are one kind of observational study. Observational studies can examine existing data for a sample of individuals. It's called retrospective. Observational studies that track individuals into the future are called prospective. So an observational study observes individuals and measures variables of interest, but does not attempt to influence responses. A response variable measures the outcome of a study, and then an explanatory variable may help or explain or predict changes in a response variable. Unfortunately, it's very difficult to show that taking... So basically, we're going to look at the language of experiments. So there's a large difference between observations and experiments. So experiment is a statistical study in which we actually do something to people, animals, or objects. So this one we're going to be acting, like we have a subset of things that we're going to be acting on to the sample that we've chosen. Whereas an observational study, we're sort of just like observing. I mean, it's in the name, but we're looking at the sample or the subset of things. And that's part. Okay, so let's look at comparison. So in an experiment, a control group is used to provide a baseline for comparing the effects of other treatments depending on the purpose of the experiment. A control may be given an inactive treatment or like a placebo, an active treatment, or no treatment at all. So the placebo effect describes the fact one, like some subjects in experiment will respond favorably to any treatment, even in an inactive treatment. So in a double-blind experiment, neither the subject or those who interact with them and to measure the response variable know which treatment a subject received. In a single-blind experiment, either the subjects don't know the treatment that they're receiving, or the people who interact with them and measure the response variable don't know which subjects are receiving the treatment exactly. So basically, so I want to give you guys an overview of experiments. So comparison, we use a design that compares two or more treatments. Random assignment, use chance to assign experimental units to treatments. Doing so creates roughly equivalent groups of experimental units by balancing the effects of other variables among the treatment groups. Control, so keep the other variables for the same for all groups, especially variables that are going to affect the response variables. Control avoids confounding and reduces the variability in the response variable. Replication, use enough experimental units in each group so that any differences in the effects of the treatments can be distinguished from the chance differences between the groups. That makes sense. Let's look at randomized block designs. So a block is a group of experimental units that are known before the experiment to be similar in some way that is expected to affect the response of the treatments. In a randomized block design, the random assignment of experimental units to treatments is carried out separately within each block. So basically, using a randomized block experiment allows us to account for the variation in the response that is due to the blocking variable. This makes it easier to determine if one treatment is more effective than the other one. So very useful. Let's look at matched pair designs, which is a common experimental design for comparing two different treatments that uses block sizes of 2. In a matched pair designs, two similar experimental units are paired and are randomly assigned within the pair. So in others, each experimental unit receives both treatments in random order. Lastly, I'm running out of time, but I want to look at inference for sampling. So when the members of a sample are selected at random from a population, we can use the sample results to make an inference about the population. Even when making an inference from the random sample, it would be surprising to estimate from the sample what was exactly to the truth about the population. So we have to consider sampling variability, which refers to the fact that different random samples of the same size from the sample population produce different estimates. So yeah, that's about it for this review for Chapter 4, which is about collecting data. I hope you guys learned something from this review. And I wanted to do some last exercises to remove any of your AP stresses. So let's get that AP stress out of your system. All right, guys, thank you so much.